Digital networking for a while now, so there's a lot of good detailed information out there. However, a lot of these guides assume you already know the basics. So in this video, we're going to build that basic understanding of voice networking from the ground up. The following two videos will take that and create a really solid foundation. We're going to start by taking a look at where digital phone systems have come from. In the really old days, phone calls went through a switchboard. This required an operator to connect you through to your destination. The building they were in was called a telephone exchange. Smaller regional exchanges are called branch exchanges. If a company was large enough, they would have their own switchboard and operators for calls within the company, as well as for connecting external calls. These were called a private branch exchange, or PBX. Exchanges still exist today, but they're very different to what we're seeing here. Of course, this was ultimately too expensive, so this became automated. We're looking at an example of a larger exchange here, but this was also true for private exchanges. This led to the Private Automatic Branch Exchange, or PABX. Developments like this meant that every desk could now have a phone, but there was no need to have a separate phone line for each desk. The basic function of the PABX is the same. It routes a call from one location to another. But over time, the PABX got fancier and offered features like call forwarding, voicemail, voice menus, and things like this. These days, the terms PBX and PABX are used interchangeably. These phone systems connected to external exchanges using copper phone lines, just like you may still have at home. But they had a lot more of them, of course. The copper phone lines connected a business to a local telecom provider's exchange. Calls into and out of the premises would route through this exchange, then probably through more exchanges until the call ultimately reached its destination. This network of copper phone lines between exchanges, businesses, and private residences is called the Public Switch Telephone Network, or PSTN. So far, this has all been using analog electrical signals. But then digital links like ISDN started to come along. Each ISDN link was a dedicated 64K circuit between the provider and the business. Each of these circuits could carry a single phone call. This is effectively where we started mixing phone calls and data on the same medium, because ISDN could also carry data. In fact, we could bundle several ISDN links together to carry more phone calls or create a faster internet connection. PBXs were getting smaller and more manageable, and now we're able to integrate the older analog lines with the newer digital links. Sometimes this meant translating between the two types. Phone networks came first. Each desk had a phone on them when computers were still only for a few users. When data networks caught up, they were entirely independent of the phone network. This usually meant separate administrators, separate cabling, and separate hardware. This is clearly not as efficient as it could be. So eventually, we started to see unified communications, or converged networks. The whole point to this is to combine voice and data onto a single network. And that's where we are today. We have phones connecting to switches, digital phone and data lines, and IP-enabled PBXs. In general, we call this Voice over IP, or VoIP. Something we're seeing more and more is the addition of video to this as well. It's not just voice anymore. At the heart of this voice network is the IP PBX, but practically we just call it the PBX. This is like the traditional PBX in that it routes calls from one location to another, both within the building and externally. The difference is the PBX now has an IP address, as it's on the data network. It may be a physical or virtual appliance in your server room, or it may be hosted by a provider in the cloud. Some physical appliances support special hardware to connect different types of phone lines like SIP trunks, which we'll talk about soon, ISDN and PSTN. But there are other advantages to putting the PBX onto the data network. For example, they can now integrate with Active Directory to build a phone number list. We can add new applications to add more features, such as dialing a number from your PC, and we can send voicemails to an email address. It's also common these days to have a mixture of hard phones and soft phones. If you're not familiar with these terms, a hard phone is a physical phone that sits on your desk. It connects to a switch with a regular data cable. A soft phone is a software-based phone installed on your PC. You can use a headset with this or a microphone and speakers. The soft phone uses the PC's connection to the data network. Regardless of the phone type, each phone has an extension. Extensions are usually a number, but in some cases it could be something else, like an email address. The PBX maintains a list of extensions and how to reach them. This is how it can route a phone call from one phone or PC to another. These extension numbers are often linked to a phone that can be dialed from outside the organisation. These are called DID or DDI numbers. As far as I know, they're exactly the same thing. One term is just more common in Europe, while the other is more common in America. These phone numbers need to be unique internationally, so these phone numbers are assigned to your organisation by your voice provider. To get these external calls working, the PBX has one or more phone lines to an external provider. ISDN is an example of this, but it's getting less and less common by the day. These days, SIP trunks are most commonly used. SIP trunks are different to ISDN as they're regular routable data links, like a WAN or internet connection. They use IP-based protocols to carry voice traffic between your site and the provider. One of these protocols is called SIP, which is why we call these SIP trunks. Previously, the number of phone calls you could have at once was based around the number of ISDN or PSTN links that you had. Now it's based around two completely different things. These are the bandwidth of the SIP trunk and an agreement you have with your provider. For example, you may be paying them to allow 5 calls, 500 calls, 5,000 calls, whatever it might be. The whole point of this section is that an organisation can have many phones, each with an extension. Extensions often have a DID linked to them, although they don't have to, and we no longer need separate phone lines for each call. Let's think a little about how this might work in a small business. Here we have a small network topology that you might see in a small organisation. We'll take a look at a much bigger one in the next video. First, you can see that the desk phones are connected to regular network switches. The port they connect to is configured with a voice VLAN. That is, a VLAN used solely for voice traffic. These phones do not plug into the wall for power. Instead, they draw power directly from the switch using Power over Ethernet, or PoE. PoE enables a switch to deliver a small amount of power, just enough to run the phone in fact. Not all switches have PoE, so keep this in mind if you're buying new switches. The phone can also get basic information about the network, as well as advertise its own features directly with the switch. It does this by using either CDP or LLDP. CDP is a Cisco-only protocol, while LLDP is supported by, well, pretty much every vendor. Now, if you're planning out a voice network, you might think that adding phones will double the number of switch ports you will need. After all, you will need one for the PC and one for the phone, right? Fortunately, no, it doesn't work that way. Desk phones have a small 3-port switch inside them. One port connects to the upstream switch, the second port is internal and connects to the phone hardware, and the third port is for the PC to connect to. This means that you still only need one switch port per desk. Does this mean that we are now mixing our regular data with the voice traffic? Also no. The upstream switch port is configured with 2 VLANs. One is the voice VLAN, which we spoke about earlier, and the other is the regular data VLAN that the PC connects to. So the phone is connected to the network and it has power. It gets some basic information from the switch using CDP or LLDP, but that is not enough. It also needs an IP address and it needs to learn about the PBX. So for this, it uses DHCP. The DHCP server assigns an IP address to the phone just like it would to any other device. However, the DHCP server is also configured with some additional options. In addition to the IP address, the DHCP server gives the phone a TFTP server address, which is often the PBX itself, where it can download a configuration file. This file contains all the other information the phone needs. As mentioned earlier, the PBX is the heart of the phone system. It can integrate with Active Directory to get a list of users and their phone numbers. When a phone comes online, it will register itself with the PBX using the SIP protocol. In this case, the phone is the SIP client, and the PBX is the SIP server. We'll look at SIP in detail in a future video. Everything's ready to make a phone call now. When one phone wants to call another, the calling phone will send a signal to the PBX using SIP. The PBX knows the IP addresses of all online phones on the network because they all registered with the PBX when they started up.